The construction is pretty antiquated. The way that projects are designed and built today is really largely unchanged for 20 years.
That is Matt Campbell, CEO and co-founder of Terabase Energy. His company is building the platform to take solar construction from manual processes to AI-driven robotics, and they just raised $130 million from SoftBank to do it.
We can process a module every 13 seconds. So depending on the module rating, you can do a megawatt or more in 8 hours. It's fully automated.
In this episode, you will learn how Terabase's integrated platform connects yield simulation, construction management, and robotics into one end-to-end workflow, and why physical AI is replacing deterministic robotics on the construction site, and also what it takes to build a gigawatt of solar in less than 10 weeks. I'm Peter Pongracz. This is Soliverse, the future of solar.
We're going to put on our own event next to the conference. We're going to do like a half-day customer workshop where we kind of have a few panels, kind of go through some of our technology and product and whatnot. So it should be good.
No, it's definitely an interesting place to be. And for you guys, when it comes to customers, is it still a lot of explaining of how the product works, etc.? I assume when we are looking into Terafab, especially that for a European market, it's a little bit different fit, right?
Yeah, no, definitely. There's we've got a few different products. So we've got sort of digital products, got some AI things we're working on, as well as Terafab. And definitely it's something very different. So people are all interested. People love robots. So people are always curious to learn more about it. European market is different than the US market, but a lot of the people in Europe are involved in projects throughout the world, right? Africa, Middle East, India. And so, in the Europe, you don't see quite the big ground-mounted systems except for Spain. So the market for Terafab would kind of be Spain, but then, MENA region, things like that.
For sure. And I mean, I would think that it would make more sense in a place like Australia, for example, right? Where you have a lot of flat land and big pieces in one parcels, right?
Yeah, definitely. It's a great product for Australia. And I think if you look at what's happening, I would say outside of Europe, the projects are getting bigger and bigger, right? So in the US, there's multiple 2 gigawatt projects that are in development or early construction. In the Middle East, there's the 5 gigawatt in the UAE. And increasingly, the projects we see on the drawing board are 2 gigs, 4 gigs, 6 gigs. And I think that's the future. Whether it be to serve the load of a large data center, and the data center clusters are getting huge, right? A gigawatt, even our partner SoftBank just announced 10 gigawatt site in Ohio in the United States. So the trend is towards these massive load centers, which would require huge amounts of solar if you want to use solar to power them. And then I still believe that the future will involve green hydrogen and its byproducts like synthetic fuels. And to do that requires just a massive scale up from what we know today. So I think that's really where, when we think about robotics, we think about going from, the world of 50 or 100 megs to the world of 500 megs to 5 gigs. And whether it's Australia, Morocco, United States, South America, these projects are here more or less. So.
Yeah, for sure. And I mean, you've touched on the market a little bit already, and also your partner, SoftBank. So you guys raised around C about a year ago, right? So that time the industry narrative was really about urgency, the power demand was and still is exploding. Data centers couldn't wait. The construction timelines need to get cut in half or even quarter, right? Now that was about a year ago. Fast forward to today. What is your take on how that urgency actually has played out?
I think the urgency is accelerating. I think that it's been unbelievable in the last 12 to 18 months where the momentum around these big data centers has just accelerated, and everybody is desperate to bring power. They say speed to power. how quickly can you get power online? And we've hit the constraints of the grid. So yeah, there's certain grids in the United States where they won't allow the interconnection of new data centers. And even huge grids like ERCOT in Texas, they're hitting their limits. And so then, how do you do more behind the meter solar? How do you integrate batteries? How do you serve the loads of the data centers? And so I think the energy around that has increased a lot. Now people are hybridizing with natural gas and other sources of generation. But even then, I mean, I think the answer is sort of all of the above. Even the Republican Party seems to have shifted in the last 3 to 6 months, where maybe there's a little bit more political support for solar that wasn't there earlier last year. So definitely, I think a lot of interest, and the market hasn't slowed down at all in the United States.
Yeah, for sure. And I mean, from my experience and what I hear from people in the market is that, as long as the maths add up, it doesn't matter what political headwinds you face, what the issue is, like everybody's voting with their wallets, right? So if you are still able to generate the cheapest power source in the world in the fastest period of time in terms of deployments, right? If you look at the graph of like how fast can you actually churn out a large solar project, I think the last data was somewhere around 16 to 18 months. So that's huge. And I think that as you can appreciate as well from the Terabase's perspective, most of that time is actually not really the construction or the actual physical build out, right? It's more about the permitting and all the paperwork around it that slows the whole project down.
Yeah, I mean, like sort of the challenge that we've set is how do we build a gigawatt in 10 weeks? And it sounds a little bit aggressive, but I think it's completely doable. I mean, provided you have your permits and all those things, but physically, how do you build really fast? And because the demand is there, and and I think this recent war is exposed once again our vulnerability to geopolitics and different sources of fossil fuel, and whether it's the effect on Europe or really anywhere. And I think solar with storage has really been the big trend, which I think is maybe we're really seeing accelerated in the United States. So, today it's lithium ion batteries, but even long duration storage is coming quickly. And as soon as you've got cheap long duration storage, you're sort of unlocking unbelievable amounts of demand.
Yeah, for sure. And I mean, you've touched on the longer term storage, right? That kind of ties into the 24/7 problem, right? That we have with solar data centers. They require 24/7 power. And then that needs to be a hybrid type of solution, whether that's solar plus storage plus even gas or wind. Basically the standalone solar days are over, right? We are only looking at hybrid projects, which will help us bring that flexibility to the grid. So what's your take on that?
Yeah, I totally agree. I think the days of doing a project without storage are numbered. I mean, I think, most of the projects we see now include lithium ion battery, but I think and then coming a few years later will be the long duration, and and there's some different technologies that are being piloted right now, but I think it's going to come, and then you can sort of get to 95% solar, and the rest you can use natural gas as a backup or something. So I think that I think we're getting really close, and I think you can do that for a LCOE that's less than 10 cents a kilowatt hour for baseload solar, which is, I think if you're in the 8 cent or 7 cent range, you're good, because the price of building a natural gas combined cycle power plant has increased a lot. And, the price of natural gas is low in the United States, but it's very volatile and exposed to price shocks that will certainly happen over the next 20 years. And now, of course, Europe's already feeling the price shocks. So it's, if you can have certainty over your cost and you're below 10 US dollar cents a kilowatt hour, I think that's pretty competitive.
Yeah, I mean, that's definitely a sweet spot. And, you've touched on the geopolitical side of things, of what's happening in Iran, and especially, how that's impacting Europe. and that's kind of pushing us in the direction of all of these more localized supply chains, right? That the manufacturing is going to come home in some way, shape, or form. So when it comes to that, of course, we are never going to be cost competitive with China, but hopefully with the right tools and the right tool set, we will be able to, manufacture, for example, modules like we are seeing in Texas, etc. And then it's going to be easier and better to meet at least the domestic demand, right? It's never going to be cost competitive to be exported, but at least the domestic demand, and hence the whole cycle of geopolitics and energy self-sufficiency will be covered, right?
The solar module supply chain is an interesting question. I mean, I think Europe, Japan, and the United States have ceded leadership in solar panel manufacturing. There's these, you've got, folks like First Solar that have done a good job scaling up in the United States. And then there's some smaller silicon module production facilities by Q-Cells and others, which are good. But I think it seems that there needs to be a lot more. Now, Elon Musk has made big announcement around 100 gigawatt of U.S. manufacturing. That is probably the scale you need to think about. Right now we have an unfortunate situation where solar panels in the U.S. cost 3 times what they do outside the U.S. And that's not good for the overall LCOE. And but at the same time, we need a diversity of supply chain. I used to make a joke like, we wouldn't want all of our solar panels in the world to be made in France, right? Nothing against the French, but you just never want to concentrate for any number. Like, what if there's an earthquake? What if there's this, so you want diversity of supply. And right now it's not the case. So, and there have been various attempts to try to build consortiums across different countries to kind of bring up a upstream supply chain. And I think those attempts have flailed. So, we'll see. India's doing some things, which is good. The U.S. is tariff heavy, but I don't think it's really getting to the root of the issue.
Oh, for sure. And of course, the LCOE dictates all of these mechanisms, right? So how do you build and at what cost do you build, which is the most important part. So, hey, just a quick moment from today's sponsor. This episode is brought to you by PVX.ai. PVX is an AI-powered solar design software built for speed and true utility-scale projects. PVX helps developers, EPCs, create optimized layouts, perform industry-leading cut and fill calculations, identify waterways, and perform soil compaction analysis. As a result, it can cut engineering time and move projects from concept to reality up to 80% faster. If you want smarter designs, higher conversions, PVX.ai delivers. You can now get 10% discount of all PVX AI products and services using the discount code Soliverse10. Terms and conditions apply. Check the link in the description or scan the QR code on the screen to book a demo and see how PVX can help you accelerate your next solar project. Now back to the conversation. Can you explain the audience, how did you guys build a company which has a vision of building the full stack of solar deployment?
Yeah, I mean, so when we started the company 7 years ago, as we spun out of SunPower, we kind of posed the question. Well, the first question was, what's the future of utility scale solar? And our theory was it's going to get really a lot bigger, both in terms of overall global market size as well as individual project size. And it's really, as I say, there's no choice, right? The solar market has to get bigger because we need that source of clean energy. And there's really no other source other than fusion, but that may be a ways off. Solar is cheap and abundant, and there's no reason we shouldn't be harnessing terawatts of it. When we looked at that and looked at the market in the future, we said, to get to terawatt scale solar, that's where the name of the company Terabase comes from, terawatt baseload solar. As we look into that future, we needed to find ways to scale the industry faster, and we needed the way to cut the cost. Because although solar is cheap, it's still too expensive in my view. Too expensive from the standpoint of we want to make it cheap enough to make synthetic fuels economically and things like that. Like if it's just solar on the grid, it's already cheap enough. But if you want to make molecules, I would argue it's not cheap enough. And because all the efficiencies and conversions and all the other things that take place. So we said, okay, we want to build a platform that allows us to help the industry grow as well as cut the costs. And then you say, well, how do I solve that problem? Well, and you say, well, the solar panel's cheap already, right? Like I like to make a joke. It's cheaper to buy a solar panel and put legs on it than to go to IKEA and buy a desk. The solar panel's cheaper than the IKEA desk on an area basis, right? So the panel has been, wonderfully high performing and low cost, but the construction is pretty antiquated. The way that projects are designed and built today is really largely unchanged for 20 years. And there's a lot of reasons for that, but it's super low tech. It's very manual in the design, manual in the project management, manual in the actual performance of the construction. And so our theory was that's got to change, and it has to change. It will change. And the way to do that is really three things: digitalization of the construction, automation of the construction, and then AI integration in the operations, right? And those three things interrelate. You need data for the AI to make decisions, and you need robots to implement the decisions, right? And so what I imagine is, we've got today where everything is manual, and then there's a point X number of years in the future where everything is run by AI and robots. And then there's this period in between that could be 20 years or 10 years. I don't know how many years, but some period. And so we said we need to build a platform that puts us on this path to this future state where solar can be built, as I said, a gig in 10 weeks, and it's cheaper, and it's, high quality and all this kind of stuff. So that's why we decided to build this integrated platform. Our sort of goal hasn't changed since we started the company. We'll start with automating the design and performance modeling, optimizing the design through permutations, simulations, and then overseeing the construction, and then automating the construction, automating the commissioning, and it's we kind of have an expression which is the cost of solar dies a death of 1,000 cuts. So we're building an integrated set of bandages. So it's because a lot of times people want to see some magic invention. Like, I've got a robot and it's going to solve the solar problem. Well, no, it's not that. It's so much more complicated than that, and that's where we look at digital systems, AI systems, data networks, material tracking, robotics. It's the synthesis of these things. Yeah.
Yeah. And on that note, I've seen, most of the software in the solar business by now. And, what I've experienced is there are too many silos, right? And what you guys are proposing, and what is essentially the kind of thought process behind Terabase, is that you guys are trying to build the end-to-end system, which is very difficult. So maybe to play the devil's advocate, if a company would want to use, for example, the best solution purely for energy modeling, the best solution purely for construction, the best for SCADA, how would you guys stack up? What is your kind of best defense against that?
Yeah, I mean, it's a good question. Best of breed versus an integrated platform. I think that we can see case studies like if you take Apple, for example. So they've really taken an integrated platform, hardware and software working really well together. And it's a really elegant, customer-friendly experience. The Apple note-taking app may not be the best note-taking app. The camera app or the photo app may not be the best apps. The email may not be the best. But as long as they're very capable, it's the integration, and same thing with like Google, like they've got an integrated suite that makes it really seamless. And, I think you can come close to best in breed. And especially with AI, I mean, it's becoming so easy to develop software. It's crazy. And so the barriers to building software are falling, in which case I think the advantages of the integration, like even within our company, I can see it where, we've got one app for our expense reports, one app for the accounting system, one app for project management, one app for HR, and it's kind of crazy. I mean, there's so many logins, so many systems, they don't talk to each other. So I think as you relate to solar workflows, I think it's okay to have, sort of a broader set of skills that are integrated as opposed to, maybe I'm not as good at PV case, but PV case is trying to do everything. It's trying to do rooftops. It's trying to do fixed tilt. It's trying to do maybe I don't care about those things. I care about big power plants with tracking systems, right? I've defined the problem more narrowly.
True. And I mean, then to a certain extent, economies of scale takes care of the rest as well, right? That you're focusing on one problem, you see the problems recurring in that specific vertical, and you are able to build a solution that's better than what's out there for sure. And on that note, if we segue into probably the most tricky word in the industry, yield simulation. So I had your colleague David Spieldener on the show before, and he's very passionate about bankability and yield simulation. So why don't you give us a quick introduction about PlantPredict and why it's better than what's out there in the market?
Yeah, I mean, so the history of PlantPredict, this was a tool developed by First Solar a long time ago to help model the performance of their modules and the projects that they were developing when they were integrated with EPC. We acquired it from them, and we've enhanced it substantially to include three-dimensional performance analysis, sub-hourly analysis, and other things. So we're really trying to say, okay, in the real world, there's topography, and there's row-to-row shading, and there's short time scale events that affect performance and stuff like that. So we're really trying to bring in a level of fidelity by leveraging the compute of the cloud so that we could do things that you can't do on desktop software. Now the interesting thing about it, and obviously PV-Syst is the industry standard, and one question that always comes up is why. They're like, oh my goodness, we're still using PV-Syst. How come it hasn't gone on the cloud? And I think in a lot of industries, and I see this in civil engineering, hydrological engineering, electrical engineering, there are tools that were developed decades ago that have become the standard. And even though technology has advanced massively, they use the old tool because everybody knows it. The banks know it. It's sort of the comfortable solution, even though everybody knows it's not state of the art, right? And I think the solar industry, no offense to the great people at PV-Syst, but I think that it's sort of where the industry is right now. Even though obviously harnessing cloud computing, we could do things you could never do on your desktop, right? So in terms of PlantPredict, I mean, the goal is to have, extremely accurate yield simulations. And then the other thing that we're doing is calibrating it off real world performance, right? So we're building the SCADA system for dozens of power plants. And what's crazy is that most performance models, they're calibrated based on a small test array, but they're not calibrated on a gigawatt power plant, right? And most of the power plants are underperforming in the United States and elsewhere. So clearly there's something that's getting missed in the modeling. So I think if you truly want a bankable system, you've got to calibrate it with the real world.
But it's funny how there is no true feedback loop, right? What you designed and actually what came out as a project and how it performs. Because again, this whole process is siloed as well, right? I designed a project, somebody else builds it, somebody else operates it, and then basically the stakeholders have very different motivation and very different views of angle, right? Of how they should be actually working. So then there is no real world feedback of how it's actually performing in the real world.
Yeah, totally agree. It's crazy. And there's a lot of examples within solar where there's no feedback loop. And part of it is it's the siloing. It's the module company makes modules. The construction company attaches the modules. A different engineering firm designs the project. An owner operates the project. And everybody's kind of guarding their data and it's not flowing. And so you're really missing a lot of opportunity to do things better, which is unfortunate. Yeah.
You guys are trying to build an ecosystem, right? So the first step would be within that ecosystem, the yield simulation within PlantPredict. If we move to the next step, how about the construction? How does, for example, a product like Construct work, and why is it different than the typical use case, or how is typically built?
So basically, what Construct is we take the construction drawings and create a digital twin, and then we bring in the official schedule for the project, which in the United States, it's like a Primavera P6 schedule. We utilize drones, we utilize other data acquisition technologies, mobile phones, other things, to basically bring in all the data about what's happening on the construction site. And then the owner and the EPC kind of have a clear view into what is happening. And it's like a single source of truth. And then we track, productivity, we track quality, we track, were things done correctly? Like if you graded the site, was the grading performed correctly? And we fly drones every week or even every day increasingly. And so like right now we're active on 62 different power plants. The total fleet that we've addressed is 25 gigawatts. And it's the alternative mostly, I mean, there's a couple other competitors that do somewhat similar things. And then also people just don't do it. They don't build a digital twin, or they fly drones to take pretty pictures, but they're really not diving deep into the analytics, right? So that's been great. I mean, I think we've seen huge growth of it, like we've doubled year over year because people really see the value into that clear view into what's actually happening on the project.
That's interesting because, we sometimes fall into this fallacy in solar that we are either in the physical dimension or the digital dimension, right? And it's quite rare to see that people would combine, hardware and software together under one roof, because they are slightly different toolkits and kind of skill sets as well to build software company versus to build a hardware company, right? But if you get the two to work together, that's where the magic happens, right?
Absolutely, yeah. And I remember talking to investors in the past, and they say, "Are you a SaaS company?" And I'm like, "No, we're absolutely not a SaaS company." And they don't like it because everybody loves SaaS companies. It's no hardware, no CapEx. But the reality is SaaS is getting commoditized, right? Like a super intelligence in a year could build a yield simulation tool in a day, right? Like, I'm not sure if it'll be accurate or not, but I mean, I guess you could do it today if you wanted. So a lot of this stuff's going to get commoditized, but you need to build linkages to the physical world. And like, if you think about AI only knows what's on the internet, right? So like the AI can go read every NREL paper and every whatever, Fraunhofer report, but it's still going to be limited on what is going on in the physical world. And that's where, I like to say the AI needs contextual awareness, like total contextual awareness. Where are the people? Where are the machines? Where's the material? What's happening? What's the weather? Like a real-time view into the physical world. It's like giving it senses, eyes and ears and nose. And so the AI needs that. And to do that, you have to straddle the physical and digital world. And then the AI needs hands. It needs to build stuff. And that's where robots come in. So you need the data to come in and then the commands to go out. And so that's where I think, without any doubt, it's that physical digital bridge, which is the key. If you want to change things.
Yeah, indeed. And there is a lot of talk on the streets, especially since the explosion of AI, right? That SaaS is kind of dead, right? It's getting, as you mentioned, more and more commoditized. But if you are able to build linkages to the real world and to be able to differentiate yourself in another manner where AI has a blind spot, and it will potentially have this blind spot for the foreseeable 5 to 10 years maybe, then it's going to really make your life much easier, which brings us to our next point, right? The the physical AI connection to Terafab, the version 2, right? So you guys have released version 1 a while ago. What is the kind of difference between V1 and V2, and how is that going to position yourself in a way of churning out those terawatt hours of solar?
Yeah, so the V2 system is so the V1 system, we did 5 pilot projects, and it was excellent learning. We worked with the big EPCs and owners in the US, and we had to deal with rats and snakes and bees and mud and snow and dust tornadoes and hailstorms. And I mean, we really got an education in trying to do robotics outside. And it was good. We learned a lot. And then we took all that learning and put it into our second generation system. And what's different about the second generation system is it's designed for really high throughput. So like we can process a module every 13 seconds. So depending on the module rating, you can do a megawatt or more in 8 hours. It's fully automated. So we take like a tracker, all the mounting hardware, attach the modules. We inspect the modules for defects. So before you even install them. And then we deliver and land the tables out in the field. So high speed, high quality, fully automated. We're setting it up for 24-hour operation. It's very portable. So of course, solar sites are very big. So you want to move the factory. We can move it in 4 hours, which took a lot of design work because it's a complicated machine. And then we also are working on, so we have this a second generation delivery rover. So this rover takes a finished good from a factory and brings it out to the field for installation. And so we've released the second generation of that, which has a number of improvements. And that was a vehicle we developed from the ground up. And, and it's all integrated with our sort of digital manufacturing controls software. And then we have an autonomous version already operating. So it's not commercially released yet, but we have an autonomous version operating. And then as it relates to physical AI, the physical AI tools have rapidly accelerated our roadmap. So we recently posted a video online, and in that video, we showed a real test that we did where the rover, our placement rover, automatically swaged a torque tube and set it down. And that was a technical goal for the end of this year, but we did it last summer. And it was because we trained an AI model to recognize all the features. And we put that on top of this very complicated actuation system. And just in a sort of an open loop control system, we were able to do this outside in different lighting conditions and with millimeter accuracy. Is incredible. And, I kind of had 2 aha moments with physical AI last year. One was when we did that, I was like, oh my gosh, like that was way easier than I thought it was going to be. And then the second was Tesla released some updates to self-drive at Tesla. I'm embarrassed to admit, but so Tesla introduced these updates to self-driving, and they blew my mind. They were so good, and it was because of the physical AI that they've integrated with the self-driving. So like we've experienced it ourselves. I think throughout the industry, it's become a buzzword, but the reality is it is transformative because the robotics that we were using previously are deterministic. I mean, it's like you pick something up and you put it here, and you pick it up and you put it here. But in outside world is dynamic.
True, especially when you mention weather conditions and hail and storm and etc. It really changes how even a human perceives the world, right? Not let alone the robot. And which brings me to, I think it begs the question of how do you guys actually juggle so many different verticals, right? Because these products are essentially like almost like small startups within the Terabase umbrella, right? And they do require very different skill sets of people to be able to operate on their own, let alone tie the whole thing together.
Yeah, well, we're fortunate to have really a large and a high performing team. So we have a couple hundred engineers. So I think it's It's about, having a well-organized plan and then executing to the plan. I think everybody at the company's extremely passionate about climate and scaling up solar. And so I think we've been able to, build a really high performance team. But it is a lot. And, we constantly have to say, what are the most important things that we're doing and what are the less important things, and, prioritizing accordingly, because it's true. We are doing a lot. I think it's just inherent in what we're trying to do. It's sometimes I use the analogy of SpaceX, right? Like SpaceX could have said, I'm going to develop software that designs better rockets. And then I'm going to call Boeing and Lockheed and try to get them to buy my software. And like, would that have been successful? And the answer is no. They had to design their own rocket, their own machines to manufacture the rocket. They had to build their own boat to catch the rocket and their own place to launch the rocket. And that, and maybe ours isn't as crazy as SpaceX, and they have a lot more money than we do. But if you really want to make a difference, sometimes it takes a huge effort, a huge investment. It doesn't, otherwise you're just like, I made this, I'm automating a CAD design. Okay, I made it better. That's great. But it's just a small piece of the overall puzzle, right? And as I like to say, there's no free lunch. You sometimes, to make a step change in an industry, you got to take, same thing with Tesla, right? They had to, who would have thought that you could create an electric car company from scratch? I mean, it was crazy, right? And then, but they did it. And sometimes it's just the only path, I guess.
Sometimes you need to take those little shots, right? I guess in the person's mind, the idea is always a little bit easier when it's born, right? But when you actually step on the path of executing, then you realize, like, okay, how many things can go differently or wrong or whatever the case might be compared to what you actually thought it would do. And that's the difficult part, right? The execution, and to stay on path and to be able to execute on your vision and mission regardless what happens around you.
It has always been an ambitious goal. But when you think about what's trying to be done here, the world needs 75 terawatts of solar, and that's more infrastructure than has ever been built. I mean, it's like all the descriptive statistics are off the charts, right? Like in terms of, enough solar panels to go to the sun and back, and, massive amounts of steel and copper and aluminum. Like, well, what needs to be done is just vast. And therefore, the solution needs to be pretty big. I think it just has to be done. And, so we're in a good position to help do it. And, I think things have proven to be harder than I would have expected. I'm kind of an optimist. I tell my wife I'll be home for dinner at 7, and it's always 8, right? No matter, I'm convinced it's going to be 7, but it's always 8, right? Like, and, it's just that as an entrepreneur, you have to have kind of an optimistic view in the world. And some of the things have proven to be hard. I mean, the outdoor robotics is extremely hard, and sort of, now it's becoming so trendy to have, robots and humanoid robots. And I kind of chuckle about it because wait till these robots go out in the mud.
It's going to be a different battle for sure.
Yeah. I mean, anybody can make a YouTube video, but it's a totally different thing to actually do real work.
Maybe if we pick a product from a European perspective, let's say Construct in Europe, how did that stack up versus your experience in the US? So when it comes to the EPC structures, the interconnection process, maybe the tracker systems as well, right? Because inherently we haven't been really using that many trackers in Europe. Now it's becoming more and more of a standard because of the Docker, right? But how is that different between the US and Europe?
Construct is, it's pretty similar, I think, in Europe, because more or less the design of the power plants, even if it's fixed tilt, is pretty similar, right? You've got rows of panels and electrical collection systems and combiner boxes and inverters and medium voltage collection and a substation, right? So the ingredients are really the same. And even if the projects are smaller, 50 megs, 25 megs, whatever, the software really doesn't change that much. So I think we see, I would say, pretty common pretty common approach. I think it's more of like when you start to think about robotics that you could see differences, and that's really where, you know, like we've designed ours specifically for bigger type deployments. But you know, a lot of Europe is a heterogeneous set of a lot of fixed till, just owing to the latitude, you know.
True. And when it comes to the one continuous workflow of a asset owner, like how is that differing, let's say, from the financial modeling through energy modeling, or maybe operations, and how are you guys treating that within Terabase?
The sort of the workflow, you know, again, we're kind of coming not from a financial model side, but from the physical asset side. You know, we'll have customers, you know, they do their energy model in PlantPredict, and then they build it in Construct, and they know the geolocation of every module and its flash test and all of that. And then we perform a capacity test with PlantPredict, which looks at the yield of the modules and the circuits and comprehends the topography, and that, you know, could get you into an instant capacity validation. And they would go into the operation, and then you can take the operational data and then compare that to what PlantPredict told you it's going to do. So I think that's sort of the life cycle, and you know, we've stitched those pieces together and really try to make that whole process much easier for the owner, right? Like even today, 99% of the power plants have somebody that's got a spreadsheet, and they're loading all the flash data and trying to figure out, you know, how much flash is on each inverter, and, you know, like then pulling out some equation and trying to determine if it's performing correctly. And yeah, we're trying to make that all seamless.
Yeah, as you mentioned at the beginning, you know, the planning is one thing, but the real world is a very different one, right?
For sure. Yeah.
And Matt, we are actually approaching the end of our time. Is there any special way that people should reach out either to yourself or Terabase? What are you guys looking for? What type of people would you like to speak to in the industry?
Yeah, I mean, we always love to speak to all types of companies, whether, or, you know, it's an owner, an EPC, an equipment OEM, another software company, another robot company. You know, for me personally, I'm just passionate about this industry. Someday I have a goal to open a solar museum, because I don't think there's one that exists. So I'm really first and foremost about the industry, and so we're always open to, you know, how can we help our customers? How can we collaborate with other tech companies? And really, how can we drive the industry forward? So, and in terms of connecting with us, of course, you can always come through our website. And then we also participate in, you know, we'll be at Intersolar Europe, obviously the big trade shows in the US and Australia. And so, yeah, reach out to us. We'd love to chat.
And we'll link to all of those in the show notes below, and I will definitely see you in Munich for sure as well. So on that note, Matt, thank you very much for your time. I appreciate you being here and sharing your knowledge. So can't wait to see you again.
Thanks. Yeah, great to talk, and have a good day. Yeah.
You too. Bye.